Welcome to your video lesson for Unit 1.4. Today we're going to be talking about vertical and horizontal asymptotes as well as holes. Okay, so vertical and horizontal asymptotes and holes appear in rational functions. So that means that the numerator and the denominator of our functions are going to be polynomials. And we want to make sure that the denominator obviously does not equal 0, because then that would just make our entire expression undefined and that we wouldn't have a function anymore. Right? So these three different components of the graphs are calculated in three different situations. Okay, so a vertical asymptote appears when the domain is undefined. Okay, so we know that the domain can be undefined when the denominator is equal to 0. So that's how we get a vertical asymptote. Okay, so we have seen that before, where the undefined value from the denominator affects our domain. We just never put a label to it. Okay, but that is a vertical asymptote. And that's how we find that, when the denominator equals 0. Okay, so we know that the graph will flatten out as it approaches the asymptote. It's going to get very, very, very close to it, but it's never actually going to cross. Okay, so in order to find the vertical asymptote, we're going to take whatever expression is in the denominator, set it equal to 0, and that is our equation. Now, important to know, a vertical asymptote is a vertical line, and so we want to make sure that we write our answer as an equation. Okay, the equation for vertical lines is x equals a number. All right, so for my first example, what makes the denominator equal to 0? So we're going to take x plus 2, set it equal to 0, okay, and we get that our vertical asymptote, I like to just label it with a VA, is x equals -2. All right, make sure that you're not just putting -2 as a number, you're putting the full equation. All right, using that value, so we know it's undefined, we want to state our domain. So if this is the only problem area in our graph, that means our domain is -infinity to 2, union -2 to positive infinity. Okay, now our second example, okay, we would have to factor any expressions that are in the bottom so that we make sure we get all of our asymptotes. Okay, so set everything equal to 0. Okay, so I have two vertical asymptotes for this, which I'm going to exclude from my domain. So I'm going to have 3 intervals. Okay, and remember, you can still use your number line. This is what it would look like for this example. Okay, so if that number line helps you come up with your domain, by all means, okay, use that. All right, so those are vertical asymptotes and putting those into our domain. All right, horizontal asymptotes. We have 3 different situations. Okay, the first is when the denominator has a greater degree. Okay, meaning you have like an x to the 4th on the bottom, and maybe you just have an x squared on top. So I actually refer to this situation as bottom heavy. Okay, so when your function is bottom heavy, okay, your horizontal asymptote is going to be y equals 0. When the numerator and the denominator are of equal degree, okay, meaning you have x squared on the top and x squared on the bottom, you're going to take the leading coefficient. So it's y equals a over b. So these are just numbers. Okay, and then your final situation is when the numerator has a greater degree. There is none. Okay, there are no horizontal asymptotes. So I call this one top heavy. Okay. All right, so we're going to memorize those 3 scenarios so that we can find our horizontal asymptotes. Okay, so now we're going to do both. We're going to find vertical and horizontal, okay, and then we're going to put that into our domain. All right, so I like to start with the vertical. So I would want to make sure that I factor anything here that's in the bottom. Okay, and we only have to use the portion of expressions that have the variable to calculate our vertical asymptote. Okay, so now for my horizontal, I'm comparing the degree. So I have x to the first in the top and x to the first in the bottom. So that means that they are equal. All right, which means I'm looking at a leading coefficient situation. So the leading coefficient in the top is 3, and the coefficient in the bottom is 2. Making my horizontal y equals 3 over 2. Okay, now when I do the domain, only my vertical asymptote is included in the domain because that's an x value. My horizontal is a y value. Okay, so my domain would be negative infinity to 4, union with 4 to infinity. Okay, this second one, we just saw this example. Okay, we know this is x plus 3 and x minus 3. We'd already done our vertical asymptotes. We know that they are negative 3 and positive 3. Okay, but the horizontal, let's talk about that. So we're going to compare the degree. So the top has a degree of 0, and the degree on the bottom is 2 because it's a squared. Okay, so this is actually bottom heavy, which means that my horizontal asymptote is y equals 0. Okay, bottom heavy is y equals 0. Okay, and again, we did this domain before. I'll just restate it. The domain only uses vertical asymptotes. Okay. All right, our third aspect of our graphs today are holes. Okay, so in order to find a hole in the graph, the very first thing we're going to do is factor the numerator and the denominator, which we've already been doing. Okay, there hadn't been anything in the numerator, but when we had the opportunity to, we were factoring the bottom. Okay, and then we're going to cancel out. Okay, cancel anything from the top and the bottom. Now, the values that you cancel, what you cancel is the whole. Wrong hole. Okay, so important that we state the whole as an ordered pair. Okay, so in order to get that ordered pair, we would just take the coordinate for our whole and plug it back into the simplified function. Okay, and I'm going to show you all of this in an example. Okay, so we're going to factor this entire expression. Okay, so in the top, I'm going to take out a GCF of 5x. The bottom is difference of squares. We've seen that a couple times today. All right, and now I'm going to cancel. So I can cancel out the x plus 3. That becomes my whole. Okay, so the whole happens at x plus 3. In order to determine what x value that is, we set it equal to 0. Okay, so the whole happens at x equals -3. We need an ordered pair for that. That's just the x value. We have to determine the y value as well. Okay, so my simplified function is 5x over x minus 3. So we're going to take this value of our whole and we're going to plug it in to our simplified function. We're going to simplify, and this is going to give me the y value. That's the y value of my whole. Okay, so I have an entire ordered pair, an x and a y for the whole. You must have both because down the line, part of this is going to affect the domain and part of that is going to affect the range. And without both coordinates, okay, you don't have a complete domain and range. All right, so now we're going to move on to our vertical. So you always use the simplified now in order to do your asymptotes. So the denominator being undefined is my vertical. So that gets me x equals 3. We need our whole, so let's put a box around that. And my horizontal asymptote, we're looking at the degrees. So the degree on the top is 1, the degree on the bottom is 1, making them equal. So we're going to take the leading coefficient. Okay, for the domain of this, we want any x values that are undefined on this function. So I know a vertical asymptote is an undefined x value. Well, guess what? Part of the whole is also an undefined x value. So even though they're coming from two different characteristics of the graph, they are both affecting our domain. So this example right here, this puts the entire lesson together. Okay, so we are now excluding -3 and +3 from our domain. Both of those make it undefined for their own separate reasons. One is a whole, one is a vertical asymptote. So my domain here, -∞ to -3, union -3 to 3, union 3 to infinity. Okay, so that is everything. Vertical asymptotes, horizontal asymptotes, wholes, and then putting it all together with the domain. Okay, please feel free, go back to look at any of these examples, pause to make sure that your notes are complete, and write down any questions that you may have, and we'll go over them when we're together the next time. Okay, thanks so much for watching. I will see everybody in